In this lesson, we're going to look at doing some calculations with uniform distributions. Let me give you a second here to read the question, and then we'll get started. In this scenario, we have a uniform distribution with the n values 5 and 18. The first question here is, I set the random number generator to provide one value. How often will this value be less than 8? So I'm first going to draw my graph. Again, the uniform distributions have this rectangular type shape. The purpose of this particular lesson is going to be to really emphasize the idea of a density function, as we'll see. Now, again, we would like to see how often I'm going to get a value less than 8, so I'm going to mark it on this graph. It doesn't have to be exact. What I really care about is left, right, and the area. Once I make my mark here, I'll shade in the corresponding area. I want values, again, less than 8. So I should be shading to the left of 8. Now that I shade my area, I'm ready to do my calculation. I'm going to type the question using, again, function notation. Notice I've called these values w, the variable w. So I'm going to write this using function notation. I want the proportion of times that I get a value of w less than 8. Now, to make clear what this is saying, this is a density function. Now, what then values that density functions provide are continuous. There is no break. Meaning the following. What's the chance of really getting 8 to come out of this? Right now, the chance of getting actually 8 to be provided by the random number generator is nil. It's not going to happen. Let me just a little quick demonstration. I'm going to go to Excel's random number generation, go to Tools, Data Analysis, select Random Number Generation, and then from the distribution types, I'm going to select Uniform. 5 is my lower value, 18. I'm going to provide, as a matter of fact, let me do this 5 columns, and I would like 30 values in each column. Make my output range B1, hit OK, and let's see what kind of numbers are going to be provided from this uniform distribution. As you can see, if I were to enlarge this a little bit, you get even more accuracy. As a matter of fact, it's giving you as much accuracy as the computer is able to. But you start to realize the chance of getting 8, exactly 8, meaning 8.00000000, even though the computer is quite limited, but it has quite a range of possibilities. You're not going to get exactly 8. So this is what we mean by continuous. So if I were to change that from less than 8 to less than or equal to, it will still come out the same. Really, the area that you see here shaded in yellow gives me the proportion of times I'm going to see a number less than 8 appear. Now, we don't need to do a normal calculation here because this is not a normal distribution. It's uniform. Area depicts frequency, relative frequency. But this is a rectangle, and I know how to calculate the area of a rectangle. This is also a density curve. So the density curve always has an area of 1 square unit. I can see that the width of the yellow rectangle here is 3. What about the height? Well, the entire rectangle has to have an area of 1. Height times width must give me 1. Therefore, the width of this is 13 units across. 18 minus 5 is 13. What number times 13 will give me 1? just find the reciprocal. In other words, the height of this being 1/13th times the entire width, which is 13, gives me 1 square unit. Now to calculate this rectangle, it's going to equal, the width is 8 minus 5, and the height is 1/13th, the product being the proportion of times I'm going to get a value less than 8, which is about 23% of the time. Let's look at another question. What value marks the third quartile? Again, I'm going to draw my picture, and there it is. And now I need to think about what it's asking. What value marks the third quartile? So I go back. What is the third quartile? The third quartile marks a position where if you look below this value, you have an occurrence of 75% of the time. So now I can see the third quartile is, I don't know, somewhere here. And here's again a picture with the correct area shaded. I don't know what this value is, but what I'm asking is, what could this value possibly be? Well, this is just kind of the inverse problem of what we just did. I know the proportion of times. I just want to know what causes, what's the separation point where you get this particular proportion. Well, I'll go back to what we did before. I know the area is supposed to be 75%. But that 75% comes from the product of 1/13 times this width right here. Now all we have to do is solve for W, and we have our result. And there's your calculation. And again, really what I want you to see from this example is that for density functions, the area for a density function gives you how often the values that appear right below it, how often they